Hey everyone. In today's video, we're going to see about feature engineering and prompt engineering, both in two different ways with different examples, where to use and how to use, what kind of engineering involved in both. So let's get started. So the evolution of AI inputs. So for feature engineering, the input majorly is about numerical. Let's say like you have tabular data where you will have features, I mean columns, and which will give back the results. So feature engineering majorly focus on minimizing the columns. So if you are having more than 2000 columns, it is not going to help the entire production, all the 2000. So you just extract the most important out of it. So that is what like the feature engineering does, majorly focus on extracting or uh, completely change the dimension of it. So you just use PCA, those things and all. So uh, feature engineering majorly focus on this, selecting, manipulating and transforming raw data into features that better represent the underlying problem to predictive models. So you just fine tune the data. That is what the entire idea is about. So it may be helpful. It may help your model or being like more, taking a versatile route towards the algorithm. So it helps in so many different ways. But in prompt engineering, how it is actually going to help, because we're going to use it for only the unstructured data. So here it comes with tabular data, and here it comes with the unstructured data where it is involved text, image, or any for sort of scattered numerical values or anything it may be. Just so you just use prompt for that, right? You can just ask the LLM to fine tune it or to get the information that you wanted, I mean the results that you wanted. So how you engineer prompt and how actually feature engineering works. So let's just have a few examples so that we'll understand better how these two um, engineering named models, I mean topics, different from each other. So feature engineering basically, you just have columns, right? As I said, like raw data, tabular data. You do the normalization or scaling the data or changing the dimension of it, reducing the column numbers. So anything you can do, and taking min max depends on the distributed, I mean how distributed the data it may be. So you just understand everything and do it. When the results, after the result, if it is not okay, you come back again and do the same step or even more of a productive way of approaching the data, you will do it. So those things are called featured engineering. So when we do this, the accuracy supposed to increase. That is the objective of doing it, and the complexity supposed to have minimal, so that it won't go back and become underfit or overfit. So yeah, so it should be uh, working understandability. I mean, the understandability should be very good, because if you are predicting something like a positive and negative comments, it should be like these comments have particular words, so we are terming that as a negative. So it is like explainable results that's supposed to be happen. It can't just randomly predict, or we can't just go with the training set predictions. So it should have like explainable amount of results, so that it should have like everything is more of that. So whenever I'll come back to that thing again. So when I talk about prompt engineering, so we do this in feature engineering. We have techniques to do that. There are like lot of topics available for it, approaches available for it. But when it comes to prompt, the first thing is you just directly give prompt minimal context. I mean, I need it to classify, or I need it to summarize it, the entire paragraph. That's all my prompt. When I give that, it just do the summary. The next step would be like little bit of context. I need to understand a particular topic in the paragraph. For example, if it is about environment, I just wanted to understand particularly about water, water resource. So it should focus on that. And whenever there is a summary, only on water resource, I need like more elaborated summary, not just 3 to 4 lines. So chain of thoughts is again my filter. I mean, the another improvisation that I'm giving my prompt that I include examples and some of the phrases which I'm seeing in that paragraph that need to be included, and also certain things if I wanted like vocabularies or bulletins like that, that I can include. So when I do that, it just include all those things and give me a proper results. So let us see few examples for each step. Yeah, for zero shot. Next. So the few shot represents it uses in context learning. So you give a specific output format so that you will get the required one. So here it is saying like negative because the prompt have been, as I said, like uh, if expected to have a certain pattern and it need to predict negative, we can use it for classification model kind of. Next, chain of thoughts, which allows it to think and process. Let's see. Yeah. So we'll get like elaborated results. So this is how the prompt actually work. When we say prompt engineering, it includes steps and it involves like a lot of development in the prompt. So that is how it actually perform. So moreover, it is majorly focused on tabular data. So the data would be like structured and numerical formats as some of it, and it is easy there so that we can process the data, analyze the data, and understand or remove, eliminate. So a lot of things add. We can do a lot of things in feature engineering, but in prompt engineering, it is very specific from human input, simple basic English, which will mission can easily understand. So it is like elaborated or straightforward or included examples. Yes, you can do that. So when to use, as I said, like for numerical straightforward data, you can go with feature engineering. If it is like organized, column based, tabular. If it is like unstructured, like text, image, or any scattered information, you can go with prompt engineering. So I hope this differentiation helps you well. If you have any questions or doubt, you can ask me. Thanks for watching. Bye.